it's kind of the self-biasing, so you only need like this current source. So again, you can start from like the minimum size of the transistor always, right? Just use like the minimum size of the transistor. Maybe your circuit is just working, right? But maybe you cannot get the enough gain. Then maybe you need to change the size of the transistors. That's what you need to do. This one is a little bit difficult because you have two stages. That is kind of the problem, right? But anyway, so the requirement is the differential mode gain is 40 dB. That means your gain is what? In linear scale, like 100, right? 100 is the gain. So you can make the gain 10 from the first stage, 10 from the second stage, then your overall gain is going to be 100. So I'm pretty sure your gain is not an issue. It's pretty easy. Without the second stage, you can get like the 40 dB. So that is not a big issue, as long as your circuit is working. So the problem is, it's not easy to make it work, to make all the transistors work in the situation. And your output dynamic range can be like the output, like the swing range should be greater than like the 3 volts. That is also pretty easy to achieve it because you only have like the one transistor on both sides. So usually each transistor took like a 200 millivolts. So this one take like 200, this one take 200. So your output voltage swing range easily you can get more than 4.5 volts. So I think that is not a big issue. The third one is called like the unity gain bandwidth is like greater than 10 megahertz. That is also pretty easy. I'm asking this one because I just want you to practice how to do this AC simulation. Alright, then what is the problem? So what you need to do? So you need to give me the schematic and the same as like the previous assignment. You need to show me the transfer curve and the output swing, find out the output swing. Then you need to run the AC simulation, AC analysis. Then what is this? Transient response. You need to schedule these things. So this is first. This is what your transfer curve, right? So I want to see like the transfer curve looks like this one. And this is called a AC response. So this is the both plot. So this one is representing the gain of the amplifier. So in my simulation, I already achieved more than what? This is 50. This is 50 dB. So this is 50, and actually I got 60, 70 dB or something like that. So it's easy to get it. So you're supposed to get, it's going to be flat, then it goes down. And what you need to do is you need to find out this crossover point. So this is your unity gain bandwidth, FU. So in my simulation, that looks like higher than 100 megahertz, right? So I think the requirement is 10 megahertz. So it's much higher than the requirement in this simulation. So 10 megahertz is over here. But in my simulation, your 0 dB crossover point is over here. So this is your FU. Okay? That's how you find out your FU. And this is just to show you the transient response. So this is my input signal, and this is my output signal. I just want to see this is nice sine wave signals from your output. You can also find out your minimum and maximum output voltage from this one, right? So you can find out output range. In this case, your minimum looks like 1 point something. Your maximum is close to 5 volts. I'm pretty sure this is more than 4 volts, like the output swing. So these are the simulation results you need to show me, right, in your report. Okay. Then let me go back. Why it's not easy for the biasing of this circuit? Because okay, like this problem. So you have a two-stage amplifiers.
Projector.
Oh. Now you have the two-stage amplifiers. So let's say the first stage is like the differential input, single output. Your second stage is like the common source amplifier. And okay, your first circuit is okay. Let's say you put. So let me give you the setup. So you can put in this way to set up your circuit. you can just use one voltage source for the biasing of what your two inputs, right? Both inputs. So when you put at 2 volts, let's say that you are going to generating 3 volts for your output voltage, and your circuit is working. It's great. Everything is working. Before you actually attach your second stage, it's pretty easy. I'm pretty sure if you are just using the minimum size of the transistor, it just works. If you only have the one stage, the first stage, it's just working. Now, great. So you just put the second stage. Now you're going to lose all the gain suddenly, because your second stage is what common source amplifier, right? So your second stage, you already designed this one before, right? In the project number 1 or 2. So your second stage amplifier, if I sketch the characteristic of your second stage amplifiers, what it said is your second stage common source amplifier is working with what? This DC input voltage, specific voltage, right? Maybe this is what, 2.8 volts. What does it mean? I need 2.8 volts here. But if you connect this one to the output of the first stage, it's not 2.8 volts, it's already set to what? 3 volts. Because the input of your second stage is determined by the output of your first stage. So it's not 2.8 volts. So where is the 3 volts? Your 3 volts is here. So you don't have any gain. Maybe your gain is almost 0.1. So although the gain of the first stage is 100, the gain of the second stage is 0.1, your final gain is now what? Only 10. So even worse than just one stage. It's always happening. So why this is happening? Because this is not the correct biasing point. So what do you need to do? There are 2 ways. The first way, you need to change this one to what? 2.8 volts. How can you do that? You can change the current for the biasing of your first stage, or you can change the transistor size. Right? You can change it. When you change your input voltage, that doesn't help you. Your output voltage is not a function of what? Your voltage, input voltage. So although you change this voltage is not going to change it. That's the advantage of what your differential amplifier. The big advantage of your differential amplifier is this voltage is not a function of your input DC voltage. So don't try to change this one to change this voltage. What you need to do is change the transistor size or biasing current. They should be changed, right? So that is one way. You don't want to do that. Okay, that's fine. Then you need to change this one to what? 3 volts, right? So what you need to do now, you need to change the size of this transistor or the biasing current of the second stage in the case. But whatever the direction you are going to use doesn't matter. But what you need to do is what? These 2 numbers should be same. That's the most difficult part of this simulation.